Okay, so we're taking advantage of shortcuts we know about quadratic equations in order to graph them quickly. Obviously, we could just say, well, let's just pick values for x and calculate values for y back like we did in junior high school until we finally get enough points that actually fit on the graph, and we'll look and see where it goes. And that works. That's how a computer works. It just does it really fast. But I kind of figure I didn't learn all this math for nothing. I might as well take advantage of stuff I've learned. So I'm going to get rid of this and say, hey, I've observed some things about graphs of quadratic equations that help me. The first thing is when we graphed enough of these things, we noticed that there was a really nice pattern in these numbers here, the a and the b, in this case 2 and negative 8, that related to the horizontal shift of the parabola as it went up the graph there. What that means is the original parabola was in here someplace, and then it got shifted back and forth by adding all these other things, and but we could learn some things about what the shift was. Here's what we observed. You can always find out how it shifted left and right by taking half of this number, finding its opposite, and dividing by that number. Or you can go whatever order you want on that. You can make it opposite first, then cut it in half, then divide by 2, however you want to do it. So negative 4 would be half of that. Make it positive. That's positive 4. Divide by 2. That tells me that the horizontal shift was 2. So that tells me that wherever it went up and down, at least now I know it went right 2. I don't know how far up and down it went yet, but I do know that it went right 2. The other thing that tells me is that the center of this parabola, the axis of symmetry, is going to go right through there. Okay? Well, so I've got the line of symmetry. That's going to be x equals 2. The vertex, this is really kind of nice here, the vertex has to be 2 something because it's going to be on this line of symmetry. So how do you find the y-coordinate? Well, I like to describe functions like this as a recipe. It tells you how to get y-coordinates when you know x-coordinates. Well, I know an x-coordinate, so let's find its y-coordinate. Okay, so we'll put 2 in here and there. So 2 squared is going to be 4, times 2 is 8, so this whole term right here is 8, minus 8 times 2 is 16, so 8 minus 16 is negative 8, plus 5 gets you to negative 3. So that tells me the vertex is right there. So now if I wanted to make my t-chart and start guessing other values of x and calculating y, I would at least know to pick ones that are near 2. So I wouldn't bother putting negative 8 in there because I'm not going to get a value that would fit on this graph. So I could do that. What I'm going to do is take advantage of another pattern that I know, and that's this. If the original function was just x squared, I know that from the vertex you went right 1 and up 1, and then right 1 up 3, and so on. Well, I now know. Pause the video. So I know that the original parabola jumped over 1 up 1, over 1 up 3, over 1 up 5, and I would get free points on the other side that are the same thing, over 1 up 1, over 1 up 3, over 1 up 5. So I know that about the original parabola, but here's the cool thing. This number here simply multiplies those jumps by that number. So instead of going over 1 and jumping up 1, it actually jumps up 2. On the next one, instead of going over 1 and up 3, it goes up 6. Right to there. So I've got the vertex and that point on the parabola, and erase these points over here. Since this is a line of symmetry, I also get a free point right there and a free point right there. So now I've got a pretty good picture of what this parabola looks like. Let's stop and check here. Have we met all the criteria? We found the line of symmetry. Yep, right there. We found the vertex right there, and we graphed the function. We're good. So now we're going to use that skill right here. This function finds the height of some object that you launched up in the air. Doesn't matter what the object is. It tells you it's gone up at the speed of 80 feet per second. You can see that right here. From a 7-foot platform, you can see that right there. This number here comes from gravitational constant. It'd be different if we were on the moon or Jupiter or something like that. But on the surface of the Earth, it's negative 16. So this function tells me what the height of that object is after t seconds. So you could put in 9, for instance, and find out how high it is, or 1 and find out how high it is. So what we're interested in is finding out how much time you have to put in here so you get the maximum height. Well, we could just keep putting numbers in for t until we get the highest number. But I want to make an observation here. First, I know from this negative that the parabola that you get when you graph this is going to be pointing down. Okay? The other thing is it's going to be shifted to the right. If you take half of this, you get 40, make it the opposite, you get negative 40, divide by negative 16, you get a positive number. So whatever this graph looks like, it's upside down and it's shifted to the right. Now, I don't know how high up it is yet, but I at least know that it's been shifted to the right. Let's figure out what that is. We had negative 40 divided by negative 16. That's the same thing as 40 divided by 16. That gets me 2.5. So now I know that at 2.5 seconds, we're going to be at the vertex. Okay? So we've answered the question. Find the amount of time it takes to reach its maximum height. 2.5. And we're done. If you wanted to find out actually how high it goes, you just put 2.5 back into this function here and find out how high it was. The question only asked you to find the amount of time it takes to reach the maximum height, and so you are done.